No pressure. Okay. Here we go. You've got a quadratic equation to solve like we did yesterday. So you're opening to page 11. I see most people figuring out your packet that you got yesterday. We're just continuing with today. And it says right there to open to page 11. And on page 11, start with this view first. Practicing factoring. While you're doing that, I'm going to take 10 minutes.
Bless you.
Israel.
Here.
Felix.
Here.
Edith. Right here. Thank you. Eli. Dahlia. Here. Stephanie. Has anyone seen her? She's here. Yeah. Okay. Yeah. Okay. Diego.
Here.
Jenny Lynn. You don't see her?
There's a backpack on the chair. I don't know.
Jamie Lynn.
Jeremy Lynn?
Play for Rocky.
I just went to a restroom.
Okay. I think
Nice save, Mom.
Sandy.
Here.
Brandon.
Here.
Brian.
Here.
Juan Carlos.
Here.
Martin. No Martin today? Lynn.
Where's Martin?
Kennedy.
Here.
Giselle. Caesar. Gustavo. Lirio.
Here.
Tyler. Melanie.
Here.
Lazaro. Jonathan.
Here.
Messiah. Where have I lost it? Joanna. Here. Kevin.
Here.
Ehong.
Present.
Christina.
Here.
Johnny.
Here.
Luis.
Here.
Anthea. Here. Brian.
Here.
You can. You have to do both. It's not X equals and X equals. There's two of them. Which one's going to be one? It's going to be the. Or you can do box. This box thing. That's what we decided to try out on these, like the original document last week, and then we'll talk together. We'll have that video, we'll do it this weekend. I'll tell you that in a second. But for right now, well, and we can do that. Flip it. Try this one. That's what I'm going to do first. So, this is your box. Know that that's for parcel dish. Change it.
Martin, you like.
He's got that.
Sign it by himself.
Who is this?
That's Martin.
That's
Martin's
Martin.
new chair.
Martin speaking?
Yeah.
All right, on that note, sorry Martin, I didn't mean to pick on you. Okay, let's see where we're at with this, because this is, if we are remembering what we're doing from yesterday, and you're feeling good about this, then this probably went pretty quickly. And if not, that's okay, you're gonna get more practice on your problem set, but maybe also think about watching the video or come in to talk to me. If you're struggling with solving quadratic equations. So, it's Friday. Happy Friday. On Fridays, I have a tradition in pre-cal. I know that by the end of the week, especially this first week, because we're conditioning ourselves back to being used to it, we're dragging a little bit, typically. And I get that, because I'm usually starting to run out of steam as well. So to liven things up, every Friday in my class is raffle day, which is very exciting, because I am a huge fan of raffles. When I was in high school, I entered a raffle. I bought some tickets from some people. I think the volleyball team was selling some tickets or something. They were doing a fundraiser, and they were raffling off a car, and I won it.
No.
My first car, fun fact, was a raffle win. It was a Mini Cooper.
Oh!
And I cruised around the rest of high school. I didn't have a car, and then I had a car. It was awesome. So, you could win a car. No, just kidding. But anyway, yeah, maybe. But anyways, that my prizes might not be that cool. But every Friday, I also try to do like weird random things. So today, we'll be selecting a prize out of my mysterious prize box, so you don't know what's in there yet, but there's all sorts of little goodies. And then other weeks, like sometimes I'll do kind of like if you played the unfair game, like I'll have folders up here with mysterious things behind that if you win, you get to pick a color, and you could win like a car, or you could win like a sock. You know, so like, so even if you win the raffle, it's not necessarily good, right? So we'll do lots of different versions. If you have your own suggestions, other times maybe I'll just like make cookies and like everyone that wins gets a cookie or whatever. So if you have suggestions for raffle too, I'm up for suggestions. But we're gonna start raffle with just kind of a normal one with some random prizes at the end. So to help us keep our energy level high with the volunteering, can someone help me out? We're not gonna really go over this, but can someone share their solutions for this quadratic for the first ticket of the year? Yeah. Let's see. I don't even remember the answer. -4 and 1. All right, very good. So raffle ticket for you. -4 and 1 is correct by using our box and seeing where we're at. Again, I'm not going to spend time like talking about all that right now. We're going to keep moving for the sake of time, okay? Okay. Quick reminders. Prom set's due on Monday. It's the first time, so don't forget it. Email me if you have questions, or call your pre-cal buddy, or do what you got to do. Also, take a look at the rubric on your syllabus, because it's been a while since I mentioned stuff the first day that might be gone. Part of it is coming from completion, from trying every problem, and part of my points are coming from accuracy. I'm going to pick some problems and actually grade them. And so look at the rubric for the specifics about how many points and stuff. And then it literally says, like, if you got 20 points, you get a 10. If you get 19 points, you get a, and so on and so on and so on. Okay? So check that out. Calculator and other supplies by Monday. Talk to me if you need help locating a calculator or aren't going to be able to get it by Monday. And last but not least, check out my YouTube channel where the videos are posted of the lessons. If you've either missed a lesson, or if you're doing your problem set this weekend and you're like, we talked about that, but I don't remember, I need to go refresh my memory. There I am. The views are steadily increasing, kind of. All right. Functions. Yeah, how does that work on YouTube?
What's the weight?
10,000? Help me out, people!
Wait,
Oh.
what is it?
It's a modification.
Oh, sorry. So yeah, you weren't here. If you just search Rebecca Cott, my old name, on YouTube, the first like 2 videos, the other ones are like other random people, but the first 2, like it'll pull up my channel, I'm pretty sure, when you click on it. If anyone's had an issue with that, talk to me, and like I said, I'll get the link out. But I think that should work. Okay? Cool. Functions time. You might have heard this word functions before. Today we're going to take a look at functions. We're going to talk a little bit about what a function is, and then hopefully we're going to spend the majority of our time, if I can pace myself correctly, talking about domain restrictions. When we saw quadratics the last few days, our domain has been all real numbers every time, right? All of the x's were good to go. Today we're going to talk for the first time about how we can write a domain when it's not all real numbers, when we have to throw some of them out with other types of functions, okay? Before we do that, in order to write a domain, they're going to start to get more complicated, so I want to recap interval notation a little bit. So we're going to actually, like, if you flip to the top of the next page, take a look at this box right here up at the top, and there are a bunch of inequalities. And I want you to, really quick for me before I talk about them, jot down the equivalent interval notation. And then once you have them jotted down, we'll kind of digest what each one means and why that inequality translates to that interval. But for right now, just jot those down for me in your notes. Oh, you got it. Jot those down for me. Few more seconds, and let's talk about what they mean. So interval notation uses inequalities to describe subsets of real numbers, so like chunks of real numbers along the number line that we're trying to talk about, okay? We use brackets, which are those ones that go and then we use parentheses, which are like the curvy ones, to indicate whether an endpoint is not included in the interval or if it is. Okay, so let's talk about a few of these inequalities and its matching interval notation to make sure we understand how they translate. But we've kind of already talked about this, so we're going to not talk about all of them. So for example, let's talk about this guy. If x is greater than a, but it's less than b, then that means it's between a and b, right? So its interval would start at a, and it would end at b. It can't be before a, and it can't be after b, so it's going to start at a, and it's going to end at b. And can someone share with me for rough to get y, if they compare it to this one, why we use parentheses for this one when we are using brackets for the first one? Yep.
It's not equal to.
It's not equal to. If it is, it's not the cup. If it is just a less than or a greater than sign without the equal to, that means we're not going to include that number, and we indicate that in interval notation with a parenthesis. If it does have an equal sign, it's greater than or it's equal to that number itself, you use a bracket to use it. Cool? But we kind of talked about that. Alright, if you've got infinities and negative infinities, like we have over there, what do you notice about infinity and negative infinity in all of those examples? Any observations over on that side? What's true about all of the infinities and negative infinities? Melanie? No, what do you notice?
No, never mind, I'm wrong.
What were you going to say? And we'll see what.
The negative infinities, I was gonna say that it happens when it's no, never mind.
Okay, so in general, I feel like you're on to something, so let me kind of like pick up. Interval notation always goes from least to greatest. It's like I'm walking along a number line from the small end to the big end. So if this is like 2 to 5, you can't write it like 5 to 2. You're saying it starts at 2 and it goes to 5 in order, like from least to greatest. Okay? So over here, with the negative infinities, notice that the negative infinities are on this side because it's saying starting off at negative infinity, I'm good, I'm good, I'm good, because this is x less than a. So all the numbers smaller, smaller, smaller coming from negative infinity until a, and then I stop at a. And again, why is this a bracket at a? A little louder? Because it's less than or equal to, so we want to include a, right? What do you notice about the bracket or parenthesis on these infinities? Bracket or parenthesis? Nice and loud. Anyone? Parentheses. On all of them we put parentheses because we can't really like include infinity or include negative infinity because it's like just a number far off there, not like an ending number that we can actually end at. Okay? Cool? Alright, a few things about interval notation. We got it. So let's take a look at some numbers, some inequalities, and see if we can write them in interval notation. We're just practicing interval notation right now so that when we do domains in a second, we know how to write things in interval notation, okay? So we got 3 examples right here that we're going to talk about, and then you're just going to practice like 2 or 3 of these in a second to make sure we're good to go. First up, I don't know if this works for you, like if I draw it on a number line. In the last class, some of them told me they liked it when I I pretended like I was like walking along a number line, so I'm going to kind of model both. So in this case, you would read that when you're looking, if it's -8 is less than x is less than or equal to 16, that means x is bigger, it's greater than negative 8, but it's still smaller than negative 16, right? So if I'm way down here at negative infinity, x has to be bigger than negative 8, right? So I have to scoot all the way along, and I'm not starting until I'm at negative 8, right? Because x has to be bigger than negative 8. So starting at negative 8, I'm good, I'm bigger than negative 8, I'm bigger than negative 8, I'm bigger than negative 8, I'm bigger than negative 8. Can I go on forever? No, at 16 I gotta stop because I can't be bigger than 16, I'm smaller than 16, right? Okay, so I'm gonna start at negative 8, and I'm gonna start with a parenthesis because I can't be equal to negative 8, okay? And I'm gonna go all the way until 16, and I'm gonna use a bracket on that one because I can be 16, it can be equal to 16, okay? And I'm excluding all the stuff on the ends going out to negative infinity and out to positive infinity, okay? That's how we would do a one like that. And on a number line, if you remember back in the day, you would open circle on the negative 8. You could do anything in between, close circle on the 16. Nothing over here, nothing over here. But you don't have to draw the picture if you don't like it, but sometimes people like it. Okay. Next one. How would we say this? Messiah, how would you say that to me, reading it? X is what? Less than 11. Okay, x is less than 11. So if I'm down here at negative infinity, am I less than 11? Yeah. So I'm going to start way down at negative infinity. I'm going to walk, I'm less than 11, I'm less than 11, I'm less than 11. And when I get to 11, I got to stop. Bracket or parenthesis? Parenthesis. And then I don't keep going because I'm at 11. And anything else would be bigger than 11. And I know x is less than 11. Copy? Okay. Last one. Then you get to try it. Woo! X is less than or equal to negative 16, or x could also be greater than 5. So we got like two things going on. Okay, let's talk about this one first. X is less than or equal to negative 16. So down here at negative infinity, am I less than negative 16? So I'm going to say negative infinity. I'm smaller, I'm smaller, I'm smaller, I'm smaller until I get to negative 16. Bracket or parenthesis? Bracket because of my equal sign, okay? And then I have to stop, but that's not the end because then there's this big or, which means I leap off to somewhere else. And then I could also be, if I'm not down there, I could also be somewhere else. Where's that somewhere else? What's the other thing saying? Or I could be what? Bigger than 5. So then I gotta jump over to 5 over here and say starting at 5, I could also be from 5 on to infinity forever. Okay? And the way we write this in math is if I have something and then I have something else, we say negative infinity to 16 union, that's what that is, that means or union, I could be from 5 to infinity on that way. That's just convention in terms of notation. When you have multiple, they still go in order from least to greatest, and you put a union. So you're not just listing them. It's still like a number line going in order with a union, showing the two separate pieces. Okay? All right. It is time to practice. We are only going to practice 2 of these because then we're going to write domains later, and we'll kind of keep practicing anyways. Joanna, can you pick 2 problems, 1, 2, 3, or 4, for all of us to do? 2 and 1. Oop, that's the end. Go ahead and try out 1 and 2, and then we're going to check them, and we're going to move on. If you have extra time, you're welcome to try 3 and 4. But I want you to focus on 1 and 2. Writing it in interval notation. Seeing how you feel about that. This classroom setup is difficult for getting out to. I didn't check your pictures, but we'll check them when we come back together. I'll just show all of them. Okay. Alright, 30 seconds. Okay, tell me all that on my TV. Just give me okay. Y'all did wonderful. There are so many people in this class. Usually I'm used to, like, as I walk around, like, anyone that's like there, I give them a ticket, but I just ran out of time. So there was like a bunch of people I saw that had it that just didn't get tickets, so I'm sorry. It's kind of like, raffle day is fun because it's also kind of unfair. Because I don't know, sometimes you get tickets, sometimes you don't. Okay, moving on. First one. Negative 8.8 to infinity. Parentheses on both, because we can't include this, and we're not going to include this. Can I question, this is my answer, am I right or am I wrong for a raffle ticket? I want to see some thoughts from the crowd. No thoughts. Jonathan, what do you think?
The negative 8.8 has to go first because it's smaller than infinity.
Because we go from the, give him a round of applause. Okay, and next, 5 to 15 parentheses on both for those of you that are wonderful and did more than that and want to check these. This would be the bottom 2 using your union like that example up there. Questions? Again, you didn't have to do all 4, but some people got there. Any questions? All right. Functions. Let's talk about what a function is. I'm going to skip. I edited my lesson from this morning because I ran out of time. I'm going to skip that big box that talks a lot about functions, and I'm going to do a quick summary of what a function is, and I'm just going to write it down right here, and then we're going to move forward, okay? It says if g of x is x squared plus 8x minus 4, find each function value. So what even is a function in the first place? You've probably had teachers that went like, this is an equation, and then one day we started writing this, and you're like, all right, it's kind of like y, f parenthesis, x parenthesis, and then we're good. But let's talk for a second about what this is. This is function notation. It's how we write something that's a function, and something is a function if for every x value there is only one y value that corresponds to it, that goes with it. An equation is a relationship between x and y. For example, here, I have 3 times what x is plus 2, and that's how I get y. That's a relationship between x and y. A function is a special type of relationship where an x value only has one y value. You might have learned this when you did the vertical line test. For example, if you have a circle and you draw a vertical line, you notice that for this x value, let's say we're at 3, notice there's 2 y values, there's 2 points. That is not a function, because it does not pass the vertical line test. If you have something like this, if you pick any spot along the line and draw a vertical line, it only crosses through 1 point, so there's 1 y value for our x value, right? And so this would, yes, be a function, and so we can write it in function notation, and we can call it a function. So you'll never write a circle with f of x, because it's not a function. That's like a quick summary. We could talk all day about it. Yep?
Can that be x of f?
No. So what the f parenthesis x parenthesis stands for is f of x, so it's a function of x because x is our input, and we're saying that it's a function relation, and so we're saying the function of x, when we apply this function to x, this is like our output, f of x.
So it can't be horizontal.
The horizontal line,
Yeah, it can't be horizontal, like you can't have like a horizontal, like if you talk about a parabola, it would
Gotcha.
have to be
horizontal line test. We will do a horizontal line test this year when we talk about inverses, but for a function, you can have 2 x's for 1 y. That's still fine. A parabola is a function. All we need to test is the vertical line test. Horizontal line test, I don't care. It could be a function, it could not be a function. Doesn't give us enough information because we're talking about 1 y for every x. Okay? Good. But we can like one-off more if you're like really curious about functions more. I can talk about it. But to make sure you feel really good about like today's objective, which is writing our domain restrictions, I'm gonna push us forward, and we're just gonna like see functions and be like, it's a function. They told us it's a function. Okay, cool. So here's a function. Let's talk about a few things with the notation. If this is g of x, and it tells you to find g of 6, then what is that telling you to do with your function, Brian?
Plug in the 6 for the x.
Literally, that means our input is, in all of these spots right here, is 6. So I'm going to say 6 squared plus 8 times 6 minus 24. You do all this crazy math, I don't want to waste time doing it. And, oh yeah, y'all are so smart, it's 60. Woo! Got it? Cool? So I'm not going to spend time like multiplying right now, because we just would solve that. Cool? Let's move on to this one. What happens when you have not just a number, but you have an expression inside? You're taking g of negative 4x. It's a little confusing when they're both x, so it might help you to think about this more as like, I'm going to draw a box instead. This is something squared plus 8 times something minus 24. What is that something? We're going to put negative 4x in both of those boxes. Okay? So we're going to say negative 4x squared plus 8 times negative 4x minus 24. Now, very important thoughts for a raffle ticket. Is this the same thing as if you wrote this?
No.
Put hands. Yes, no, maybe so, why not? Y'all are so funny. It's like half the class, no, and then it's like hands, and it's like, no one's got it. You don't want raffle ticket. Here, I got an idea. Tyler, thanks. Tyler, yes, no, maybe so, is it the same, is it different, what's your gut telling you? Not the same, okay. Do you have an idea of why? Do you want to extend on that, or no? Mosiah does? Okay, Mosiah?
I'm thinking that the exponent is distributed to both variables.
Okay. If we write it like this, that squared, you're telling yourself or your calculator, wherever you're writing this, that it's only on the x, but we are squaring the box, which means we are squaring this whole thing, which means we're squaring the negative 4, and we're squaring the x. And what's negative 4 squared? Negative 4 times negative 4?
16.
And x squared is just x squared. So like both of them, this is very different. Both of them end up needing to be squared. So just be really careful. Okay? So 16x squared minus 32x, because 8 times negative 4 is negative 32, minus 24. Ta-da! That would be what we get when we simplify things after we plug in negative 4x. Okay? Alright. I want you to try, I think we're going to be good at plugging in numbers as our input. So I'm going to have you try one of these expressions. Try out B. Plug in 6x to your function and see what you got. Do you mind me come back and pass back up here? And yes, well, I was like, gonna come get someone else to get people working hard in the back, because I know I missed y'all last time. From here, you actually have to stop. Cancel these. I'm gonna talk about one with each other, so it's like what people are doing all day. You can only cancel if this is 12x times 3. You can't cancel across addition or subtraction. You can only cancel factors. So they're gonna be with fixed multiplication, so you just gotta stop. Okay? Okay. We're back with whatever you got. Some of those people I think get there. For this one, plugging in 6x. On top, we end up with 12x plus 3. And on the bottom, we end up with this quadratic down here. Make sure you squared the 6 and the x squared. Okay, the last note about this before we move on. Couple questions today about whether, simplifying this more, whether we can cancel 12x and that 12x that we see on the bottom, because it's like the top and the bottom. Can we cancel it? Looks good to me. No! Can't do it. So let's talk about why. You can cancel in cases like this across multiplication. If this is 4 times x over 4, 4 divided by 4 is like 1. And so we can cancel it and say that we have 1x, right? In this case, we have 12x plus 3. We don't have 12x times 3, and so we can't cancel that 12x unless it was like a factor, right? So the only other thing that you could check is like when we factor this, if you can cancel a factor once you write it as multiplication. But I'm going to go ahead and just like leave it where we're at for right now. We can't cancel the 12x's though, because then we got addition and subtraction going on, okay? So we're just going to leave it like that, and we're good. Cool? Alright, so you've got a few of these on your problem set to work on this weekend. The last thing you'll notice on your problem set is domain restrictions on our function. So that's where we're going to spend the rest of our time today. And this is getting into some of our more challenging like pre-cal stuff. So stick with me. We're going to get through it. Okay? Alright. In general, I mentioned this earlier, right? Negative infinity to infinity, all real numbers for our quadratics that we looked at. Okay? So let's talk about some of the issues we run into with other functions that cause us to not include all of the x values. Right? Like when are we gonna like have issues? Let's talk about it. When you're given a function with an unspecified domain, the implied domain is a set of all real numbers for which the expression used to define the function is real. That's saying right here that a lot of times when we don't define it, or it's not as big of a deal, because a lot of times it's just negative infinity to infinity, you're good. Sometimes, in general, you must include values from the domain of a function that will result in two big things we're going to talk about. First issue you might have with a function is division by 0. If you have 5 divided by 0, Martin, is your calculator on, or does it take long to load up? You're on. Anyone that's got the calculator right in front of them, type in 5 divided by 0. What does it say? undefined. That is not a real answer. So you cannot say like all real numbers. If you get 0 on the bottom, we have an issue with our function there, right? Okay. So division by 0 is going to be an issue, our first issue that we run into. Okay. Our second issue we'll have is having the square root of a negative number. The square root of negative 25 is not negative 5. Does anyone remember what happens when you have like square roots of negatives?
It's like an I or something.
You talked about imaginary numbers possibly? Okay, so since it's what we call, it has to deal with like the realm of imaginary numbers, that is not real numbers. So again, we're not in negative infinity to infinity. Like we're having an issue, this is not a real solution. And so as a result, those are also issues we're going to run into where we've got to exclude values that are causing that to happen in our domain. Okay? When we had things like this, 2x squared plus 3x plus 5, there was no division by 0 that was going to happen because there wasn't even like a denominator, right? And there were no square roots, and so we weren't going to have the square root of a negative number, so that's why we were good to go, all real numbers. Okay? Let's talk about something that looks like this. Oh, and notice my handy dandy poster. It's in your notes. Well, like as we move on with our lives throughout this unit, I will have this around for you to remember our 2 main issues we're going to have when we are looking at a domain, all right? So, let's look at this function. And we want to state the domain. We're looking for the domain using interval notation. So that's why we practiced interval notation earlier. We want to know what x values we can have. Okay. Observing your function and observing these 2 things, where do you think we might run into an issue? Division by 0 or taking the square root of a negative number? Really quick, tell your neighbor which one you think might be the issue, and then I'm going to call on someone random from the sticks to help each other out. Which one do you think? And why? Which one do you think? So what do we have here? That's not we have division, so we're going to go back here. Alright. What about y'all? Want to tell me anything? Okay, here we go. Gustavo? Is that this class? Okay. Gustavo. Which one do you think? Safe, space, what do you think?
We weren't sure, but just because there's a square root, I say square root.
Just because there's a squared, right? He says there's squared. He's going to say maybe the square root. Anyone else in here? Raise your hand if you said the same one. Few people? Okay. It's okay. I'm not giving anything away. Pass that back over there. Okay. Anyone think the other one? Division by 0? Okay. I see a few hands. Why were you thinking that, Brian?
Division.
Because there's division. And so if this ends up being 0, we might have a problem. Okay. Is that your laugh at my voice? Sorry, you'll get used to that. Happens a lot. Anyways. So, I've had a lot of people today that have said with like the square and the square root, but you'll see examples in a second, don't look, where we literally have square roots, where we have to make sure that we don't end up with a negative underneath there. With just a square, could we square a negative number? Can we do -1 squared? Yeah, -1 times -1 is +1. So, we're okay with squares. But I know they're related, squares and square roots. The issue that we're kind of concerned about here is if this bottom were to be 0, then our function doesn't have a value because Martin plugged in his calculator earlier and whatever's on top, it doesn't matter. We don't actually care about the 2 plus x. Whatever's on top, if we try to divide it by 0, we're going to get undefined like Martin showed us. Okay, so here's what we have to do. We have to figure out where is the bottom 0. I don't even care about the top. I'm going to set that bottom equal to 0 and solve for which x values give me 0 so that I know that bad x values. We don't like those x values because it gives you 0 on the bottom. Okay? We don't like them. We got to get rid of them. Okay. X x squared minus 7x, we're used to seeing things that look more like this, that have a number out here from yesterday, okay? But you can still factor things that look like this. Does anyone notice a common factor or something we can pull out of this? Yep.
X.
X. You can pull out an x, and you'll have x left here, and what will you have here?
7.
Minus 7 equals 0. Really quick check using distribution. We get x squared minus 7x, right? So fun fact, we didn't really do examples like this yesterday, but this is also factoring. When you don't have a c value, it's kind of nice because since they both have x, you can just pull one x out front, okay? Now we've got our zero product property. If our product is 0, then one of these things or both had to be 0, right? For this to be 0, x would be 0, right? If x was 0, the whole thing would cancel out. So x equals 0. That's going to give us 0 for sure. Bad. We don't want that. Okay? And what about this one? X would be what? What would give us an issue and give 0? 7. X is 7. We're going to get 7 minus 7 is 0. And we got 0. Like you can check. You can bring it back here. 0 squared minus 7 times 0. See how we're going to have 0 on the bottom, the denominator? No, we don't want it. Okay? So, your answer is, like in your own terms, that it's all real numbers except for 0 and 7, right? Good. That's step 1 of understanding the domain. However, they asked for interval notation, which means just saying that is not good enough yet. We now need to express that like we did earlier, walking along the number line in interval notation, okay? So let's start down at negative infinity. Is negative infinity going to be okay? Like numbers way down there, like negative 100. If you plug them in, are you going to get 0 on the bottom? No. You're good, you're good, you're good. So we're going to go from negative infinity. We're coming along, we're coming along. We're good, we're good, we're good. Where's the first number we got that gave us 0? 0. Just happens to be the same. Okay? And I'm going to put then a parenthesis to say I don't want that number. Cool? I want everything right before it, and I want everything right after it, but I don't want 0 itself. Okay? So I'm going to say union. I'm going to keep going. I'm going to pick back up at 0 without including it, because I want everything just past it, all the way to what?
7.
7. And then I have to put a parenthesis because I don't want 7. And then, this is crazy, we haven't even seen this yet, but we actually want more, right? We want past 7. So union again, you just keep on going. I want 7 forever on to infinity.
7 is underneath.
Parentheses all the way, because negative infinity and infinity always have parentheses because they can't include them. And then I don't want 0, and I don't want 7. This is how to say all real numbers except for 0 and except for 7. That's how we would write it in interval notation. Okay? So like first thing for your brain to handle is just the domain stuff itself. Like how do we solve for these issues? Where'd it go? Oh. And then writing it in interval notation is kind of the other piece. Okay? Alright, I know I'm talking a lot. We're going to get to some practice. But I want to give you an example with a square root. Okay? So let's try this. Up next, the square root of t minus 5. Do we have to worry about dividing by 0? No, we don't have a fraction, like, we could have 0 and we'd be fine. We can have 0 as long as it's not on the bottom. Okay? So the only thing we have to worry about is if that stuff inside the square root is negative. Luckily, it's kind of a similar process as the last one, because when things change from negative to positive, the like crossing point is 0, right? So again, I can set this thing equal to 0, kind of like before we set the bottom equal to 0. Now I'm going to set what's underneath my square root equal to 0, so that I can figure out where